Hello everyone, Mr. Sutherland here. I hope that you are all doing well. Today what we're going to learn is a little bit about the connection between the two forms of the quadratic equations that we've worked with this year so far. So let's do a little two review problems. Okay. And what I would like you to do for each of these problems is I'm going to give you a quadratic function, and I'm going to give you a quadratic function that one in vertex form and one in standard form. And I would like you to tell me which direction the quadratic opens. I would like to know what is the axis of symmetry. And then the axis of symmetry for this one. And then I have the vertex for each one. Some of these, it takes a little more work for one part than the other, so I'm going to space these out. You can space them out whatever you need to as you're doing these problems. And then we will do the y-intercept for this and the y-intercept for this one. And then we will talk about the range of each graph. Okay, so the first one. For the first one, let's make this one -3 x plus 1 squared minus 4. And for the second one, for that one, let's do x squared minus 6x plus 12. All right, so the first one, this is called vertex form, and the second one is in standard form. So what I'd like you to do, pause the video and see how much of this information you can do on your own, then unpause the video and let's take a look and see how to do each of these. Okay, we're back. So let's do everything with the vertex form first. I'm going to go maybe in a different order than what you see here. First thing I know is that this is a parabola that opens down. And I know it opens down because the -3 out front here. The vertex of the parabola. When it's in vertex form, the vertex is easy to find. All we do is we look at what's in parentheses and we do the opposite. So since it's x plus 1, -1 is the x coordinate of the vertex. And here for the y coordinate of the vertex, you do -4, exactly what you see at the end of that equation. Axis of symmetry, I do that. In this form, I do the vertex first. Axis of symmetry, remember, is this vertical line that cuts it in half, and it's always x equals whatever the x coordinate of the vertex is. So this one is x equals -1. I'm going to head and put my vertex here on my little sketch. Now the y-intercept is the one that requires the most work in vertex form. Remember, to find the y-intercept, I'm going to make x 0. So if I make x 0, I have -3 times 1 squared minus 4. Well, that becomes -3 minus 4, which is -7. And now my range, for the range, I look at the y value of the vertex, and range is your y values. And in this case, all my y values are smaller than -4. So this is vertex form. This is what we were doing before we left for spring break and the break because of COVID-19. That's where we were. Now, what we've done that's new is standard form. So with standard form, which way does it open? Again, I look at the x squared term. There's nothing here. Remember, if there's nothing there, I can always put a 1. And so that's positive. So this is going to be a parabola that opens up. So I'm just going to sketch a parabola that opens up. Now the axis of symmetry for this one is the one we've got to use that new formula we learned a couple of days ago. And that's where I do the opposite of the b value. So instead of negative 6, it's going to be positive 6 over 2 times the a value. So 6 over 2 gives me 3. Now, that, remember, is the x-coordinate of the vertex. To get the y-coordinate of the vertex, I plug 3 in for everywhere that I see an x in my equation up here. So I have 9 minus 18 plus 12, so negative 9 plus 12 is also 3. So I have a vertex at 3, 3. We have our axis of symmetry. My y-intercept, I love doing y-intercept from standard form because all we have to do is look at that c value, because if x is 0, this goes away. The negative 6 times 0 goes away. We're just left with 12. And now the range, I've got my y values, I've got the 3. All my y values are greater than or equal to 3. So this is really what we've done the last couple of blocks. The one on the left, number 1, was what we were doing previous and a little bit after spring break, and then number 2 was the new topic that I introduced on Friday. Now, we can go from one form to another pretty easily when we're going from vertex form to standard form. So, standard to vertex is a little tougher. So this is the new content. So what we want to do is we want to be able to go from vertex form to standard form and kind of analyze the graphs and see that they are the same. So let's do example 1. Let's say I have f of x equals 2 times x minus 1 squared plus 3. Okay, so what I'm going to do is first analyze the graph and as I see it here in this form. So it's given, it's in vertex form. We have that the vertex is at the point 1, 3. Remember, we do the opposite of what's in parentheses, so x minus 1 becomes 1, and then the y value is 3. And then for the y-intercept, we have to do work for that. That's one where we make x 0. So I have 2, and 0 minus 1 is negative 1 squared plus 3. So 2 times 1 plus 3 is 5. So I get 0, 5. Now, what I want to do is show you that if we convert this to standard form, we should get these same things, that the vertex is at 1, 3, and the y-intercept is at 0, 5. So to convert to standard form, what we do is we take the function and we perform the mathematical operations that we see here. So the first thing we're going to do is we're going to do the x minus 1 squared. Remember, order of operations, the first thing we're going to do is parentheses. So remember what that means is, that means I've got x minus 1 times x minus 1 plus 3. Now, we need to multiply those out. I'm going to do that over the side here. This is what we did last chapter, where you could use the box method, or we could use the distributive property. So I have x times x is x squared, x times negative 1 is negative 1x. Negative 1 times x, negative 1x. Negative 1 times 1 is 1. So I get x squared minus 2x plus 1. So I'm going to substitute that right where I had that boxed in red. So I got x squared minus 2x plus 1, and then we had the plus 3. So now I can distribute the 2. So I have 2x squared minus 4x plus 2 plus 3, and now combine like terms, and in standard form I have 2x squared minus 4x plus 5. Well, look at what we have here, everyone. We had in vertex form, we found the y-intercept to be 5. In standard form, remember, there's the y-intercept. They match. We got the vertex. Let's see if it's in standard form. Remember, I've got to use opposite of b. So instead of -4, it's +4 over 2 times the a value, which is 2. 4 divided by 4 is 1. And then if I plug, so I get the vertex here, the x coordinate to be 1. And if I plug 1 in for x, I get 2 times 1 squared minus 4 times 1 plus 5. So 2 minus 4 is -2 plus 5 is 3. Look, that's the exact same thing we had there. So both of these equations, if I were to graph them, would give the exact same parabola, the exact same graph. One is in vertex form, but we can always convert vertex form to standard form. So let's try one. I don't want you to do any of the analysis. All I want you to do is convert f of x equals 2 times x plus 3 squared minus 4 to standard form. So pause the video and see if you can do that, and then unpause and come back and let's see how you did. All right, let's take a look. So the first thing I always do with these is I take care of that guy squared, the x plus 3 squared. So remember, what that really means is I have x plus 3 squared, when means x plus 3 times x plus 3, and then I have the minus 4. So in order to kind of make this a little neater, I'm going to take this out and do that multiplication over to the side again like I did last time. This time I'm going to remind you how to do this if you want to use the box method. So I have x plus 3, x plus 3. So this is x squared, 3x, 3x, and 9. So if I combine like terms, I get x squared plus 6x plus 9. So now I'm going to substitute. This is now x squared plus 6x plus 9. Now I'm going to distribute the 2. So I have 2x squared plus 12x plus 18 minus 4, and now combine like terms. So 2x squared plus 12x plus 14. So the new skill I want you to be able to do today is take something that is in vertex form and, using some skills that we've learned over the course of this year, convert it to standard form. I hope you all are doing well again. I miss you guys, and we will see you again soon, hopefully. Take care.